So next up, we have Giovanni from Google. He's going to talk to us about, we've been talking, if you're talking DevOps, there's a lot to talk about automation. I think that's a really important part of DevOps and cloud. And Giovanni will tell us more about how to automate your builds and test and deployments in a multi-cloud environment. And I also think there will be some demo stuff, which is always fun. Over to you, Giovanni.
Thank you. Thanks a lot, Marcus. So as Marcus was saying, in this talk, I will try to share with you an example on how to create a software delivery pipeline using mainly GCP developer tooling, but deploying in different stages where these stages are hosted on different cloud platforms. I am Giovanni Galloro. I work at Google as a customer engineer focused on application modernization. I work with the organization in helping them to modernize their existing application or deploy new application using mainly Kubernetes, cloud native architecture, service mesh, and DevOps and continuous delivery practice. And talking about DevOps, I want to start with a bit of research. There is a team inside Google called DORA, DevOps Research and Assessment, that since years performs research on the performance of the organization that delivers software, that produce software. These teams come from an acquisition. It was a company called DORA, and the founder of this company are also the authors of a book that is quite famous in the software delivery life cycle world. It is Accelerate, and since years they share the findings of this research. That, by the way, is a research that has a rigorous approach and also is quoted also by other analysts, and they share the output of this from this research with a report called the State of DevOps report. What this research found is that the organizations that have a good performance in delivering software are also most likely or twice likely to overachieve their goals in terms of revenue, customer satisfaction, and productivity. This is not a surprise. This doesn't come as a surprise. What is more surprising or less expected is that the speed and the agility are not in contrast with the stability. So what this research found is that typically the organizations that excel at speed, they also excel at stability. The two things are not one against the other. The research takes into account many factors, technological factors like the usage of containers-based architecture, immutable infrastructure, automation tooling, or also process factors like the adoption of all the processes related to continuous delivery, or also cultural factors like the communication between teams, the different teams inside the organization, and also considering the failure as a normal component of a complex system, the so-called blameless culture that is part of the SRE approach that it's also common inside Google. And it extracts 4 key metrics, the 4 keys as we used to call them. 2 are related to speed and 2 are related to stability. Related to speed are the deployment frequency, so how often I update my software in production, how frequently I deploy my software, and lead time for change, the time that passes from when the commit is done on the source code and this feature is available in production for all users. And 2 are related to stability, the change fail rate. So when I deploy, how many of these deployments actually fail, and the time to restore service. If I fail and when I fail, how long it takes to recover. And based on these key metrics, the research perform a kind of grading between the organization, comparing the so-called top performance or elite with low performance. And here you can see some differences where the top performance are deploying 200 times more frequently than the low performance, and have a lead time that is 100 times shorter. From the research, coming to the tooling that we have on GCP to help optimize delivery pipeline, software delivery, we start from Cloud Code, that is an extension for common IDEs to help developers to optimize their developer work. Cloud Source Repository, that is a managed Git compliant repository. Cloud Build, that is helps to orchestrate all the tasks related to application build, to continuous integration. Artifact Registry, that is a managed artifact registry that lets you create repositories to store container images, so it's a kind of managed container registry, but also binary artifacts from application building, application compile, and that you can create this repository, regionalize them, and also implement permission and access control of them. And Cloud Deploy, that takes the output of Cloud Build, takes the output of continuous integration, and let you automate the deployment in different runtime environments and different stages. The runtime environments are this one, as you can see, are runtime environments running on Google Cloud, like Kubernetes Engine, Cloud Run, or Cloud Functions, but also what we call Anthos cluster, and we will come to this in some minutes, and this is part of the topic of this talk, where the deployment environment can be environments that are outside Google Cloud Platform. And then last but not least, cloud logging and monitoring, that are managed components to have logging, monitoring, and tracing of your applications without having to implement or manage logging and monitoring infrastructure, for example, and that provide this final feedback loop to a DevOps pipeline when the application is in production. Let's see a bit in more detail these components, or the main components I talked about. Let's start from the inner development loop. That is the time that passes for the developer from when he makes changes, developing a new feature or refactoring code or fixing a bug, and when he sees the output of this change. To help in that area, on Google Cloud, we provide Cloud Code, that is an extension for most common IDEs like VS Code or IntelliJ, or also we provide it as a cloud-hosted IDE, that is the Cloud Shell Editor. We will see this in the example, and it continuously build and deploy the work of the developer, the output of the developer, on a target Kubernetes test or development cluster. So in this way, this kind of inner development loop become faster. On the next step, on the continuous integration, in the continuous integration part, where from when the developer actually commit his code to the repository, we have Cloud Build. Cloud Build let you orchestrate, automate the execution of the step related to a continuous integration pipeline, to the build of an application. Steps that are, for example, the compile of the code, the build of the code artifact, the binary artifact, with all the related testing, unit testing, for example, or the build of a container image, or the push of a container image on a repository. And all these steps are run as an ephemeral container in a fully managed environment. So when a step has to run, a container is started, the step is executed, and then the container is destroyed. You don't have to manage a continuous integration server. You don't have infrastructure to manage. This is run as a managed environment in a Google managed project. And all these steps share a workspace storage environment where the artifact product from a step is shared with the following steps, so in order to preserve the artifacts between them. These steps are orchestrated as a pipeline that is configured with the Cloud Build configuration, and we will see that in the example, and can be linked with a trigger to an event that happens on the source code. So you can have this pipeline starting when you have a push on a branch or an event on your source code. And the end state of this pipeline is typically putting a binary artifact or a container image that is the product of this build execution on a container repository, an artifact repository, in our case, typically artifact registry. And then let's come to the deployment. Now, we talked about the coding, we talked about the build and the continuous integration, and let's come to the deployment. The deployment on GCP is managed by a tool called Google Cloud Deploy, that it starts where Cloud Build finishes. So it starts from the image, the product of the continuous integration, and attached to it the specific configuration for each environment. So it manages the deployment of our code, of the developer code, in the different environments following a pipeline, and the promotion in different environments, rendering the manifest, typically where the environment is a Kubernetes environment, applying a configuration that is specific for that environment to the image and to the release, and managing the deployment. Here you can see some of the resources used by Cloud Deploy. One is the delivery pipeline. The delivery pipeline describes the progression of the code in the different stages and how this happens. It uses some targets. Targets are deployment execution environment, typically GK cluster, also non-GK cluster, as we will see, and also Cloud Run. These are the environment supported at the moment. These are resources that are managed by Cloud Deploy. Another important resource is the release, the concept of the release. The release is a connection between a specific container image, a specific software release, with a delivery pipeline and its targets. Okay, so it's an association between the code and the delivery pipeline, and then there is the rollouts. Then in turn is an association between the release and a specific target. So a rollout is a specific instance of a release in a specific target. As I was saying, the object of this talk is deploying not only on Google execution environment, but also beyond and outside Google execution environment. Recently, we released in public preview the possibility to deploy also to non-GK cluster. This is in public preview, so there could be some changes in flight, so don't shoot me if something is not perfect or this doesn't work. I like to learn in public and do live things, but I hope that everything would work. How this works, actually. To introduce how this works, I have to introduce Anthos. Anthos is basically a Google platform for deploying container-based application that has Kubernetes as its foundation, that extends the possibility of having a Google provided Kubernetes outside Google Cloud. So on AWS and on Azure, with Anthos on AWS and on Azure, so a managed cluster on AWS and on Azure, on-premises, interacting with enterprise virtualization platforms or with existing Linux distribution, but also onboarding non-Google provided Kubernetes, so using, as we call it, attached cluster, and managing with Anthos clusters that are not provided by Google, like Amazon EKS or Azure Kubernetes Service or OpenShift, for example. And all these clusters can be managed by a single pane of glass by the GCP console. How this happens? This is important because this is the same tooling that is used to deploy outside GCP. This is managed by a component called Connect Gateway. Connect Gateway is a deployment that runs on the managed cluster and that open an outbound connection to Google Cloud public APIs, an outbound TLS connection, an outbound HTTPS connection, and inside this connection opens a gRPC tunnel from which the cluster can be managed. So it proxies the operation that you do on Google Cloud APIs on the target Kubernetes API server. So this, obviously, the user doing this needs to be authorized, needs to have the right roles or cluster role on the cluster. But this let you manage the cluster without opening inbound connections to this managed cluster and without exposing the Kubernetes API server externally. So let's have a look at how this could work. Let's have a look at our example. I have, if you can see, I have two clusters registered in my GCP console. One is a GK cluster, an expected GK cluster, and one is an EKS cluster. This is an Amazon EKS cluster connected with the Connect Gateway to GCP console and to Anthos. We can see it also from the AWS console. Okay, and I have configured the Connect Gateway, as I said, to manage this cluster. If we look at my kubeconfig configuration, I see that to connect to this EKS cluster, I'm not connecting to his API server, but I'm connecting to a GCP endpoint, a Google APIs that actually proxy my commands to this EKS cluster. Okay, this is part of our example. Another part of our example is application code. I have an application repository. It runs on my personal GitHub account, but this could be typically an enterprise or an organization GitHub repository where the application resides, probably managed by the application team, the lead of the application development for this application, or the quality assurance team. And then I have a developer that is called Michelangelo, and it actually uses a different Chrome. I'm using a different Chrome, different browser to perform the activities of this developer. He forked this repository on his own GitHub account. He copied locally. And here you can see the Cloud Shell Editor, what I mentioned. So the cloud code deployed as a cloud environment where I opened the repository. One important thing in the repository is the Scaffold file. Scaffold is an open source tool developed mainly by Google, but it's important in all this pipeline. It is the underlying tooling under Cloud Code. It is the underlying tooling, or better, is used by Cloud Deploy, and in our example is used also by Cloud Build. Is the tool that helps to continuously deploy the output of the developer work on a test cluster, and we will see this in a minute. So here we will see that the developer developing his application, testing his application locally, and then when he is happy, he will create a pull request to the main repo. And to this pull request, there are some triggers linked to it. So there is a trigger, a cloud build trigger, like the one I was explaining before, linked to the central repository that runs when a pull request is created. Let's see if I see it. And it executes the steps that are defined in this cloud build configuration that I can see also in my copy of the repository. Let's see. Okay. So basically what this does is running a scaffold build, scaffold again. So we use the scaffold also to build a container image, this time not used for development. This is a container image that will be put on an artifact registry repository, okay? And then this trigger will use gcloud deploy release, is the client part of gcloud deploy, to create a release on Cloud Deploy and associate with this multi-cloud pipeline, so with this deployment pipeline that I have here. I have this delivery pipeline here with two stages, two targets, QA and prod, okay? And these are the targets. QA is my Amazon EKS cluster, so let's assume that the QA team has want to standardize everything on AWS, and the prod is a GK cluster because maybe this application needs to run near a data warehouse that is running on GCP.
Hi, we are Ethicode and we organize the DevOps conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at ethicode.com. The links are in the description. And have a great time with the DevOps conference talks.
So when the developer creates a pull request, the QA team actually, before merging the request, the automation that build the image and deploy the image on Amazon. And then there is another trigger that when the pull request is merged, deploy the application on the production cluster on GKE. So let's try to see how this works. This is the developer workflow. As you can see, the developer start to work. We started this continuous deployment on a development cluster that in this case is managed by Minikube. So Cloud Code provides Minikube both running locally in a developer workstation that on Cloud Shell editor. So we should see this build happening and Scaffold and Cloud Code doing connecting and doing port forwarding on Minikube. If demobots are with me, let's hope so. And let's see the application code. Okay, this is an application that basically say Leroy app running in Target, and it get environment variable that is different through scaffold profiles and the different target on Cloud Deploy is different in all the deployment. So as I said, the developer can see the output of his work. Now the application is deployed in dev, and it's here. And if the developer change, the file is auto-saved, and this is continuously updated. Okay, so as you can see, I don't have to save the file. This is continuously updated, and the developer can see the output of his work continuously. There are other things that can be done, debug, scene log, and things like this, but I don't think I have time to show that. If the developer is happy, he can add the file he changed commit as a new feature and push this change. Okay. I didn't cache my credential. Let's see if I have a token. Okay. And then the developer can open a pull request to the main repo. The developer create a pull request. There is a check because there is a check associated with the cloud build trigger. A check that is failed because I didn't show it for the time, but I have the trigger configured in a way that the trigger starts when the owner of a collaboration of this repository create a comment with the GCB run inside to have this trigger happening. So if I go to the repository, I am a member of QA team, I see the pull request, I see this pull request, I can check the changes, but I don't want to match. I want to see how this works in a quality assurance environment. I want to perform some integration test for that. So I put this comment inside, and so a GitHub check start that it queues the execution of the trigger. The execution of the trigger that actually build the image, and in this case, build an image, a new image. Maybe is not the same image the developer used, because the image the developer used it's okay for his environment. This should also embed dependencies that are needed in the quality assurance environment. Okay, this is queued, and this should start hopefully soon. Okay, as you can see, the trigger start. Now these are the cloud build step that pull the image of the builder that needs to run. And this is the scaffold build, the first one that will build the image, and then there is G-Cloud that will create the release on the cloud deploy. And when a release is created, the release is also there is a rollout created on the first stage of the release. So I will see when this is completed a release rolled out on the quality assurance environment. There is an Anthos cluster, an EKS cluster actually. So let's follow through this. If is building the application using the commit SHA, the short commit SHA. I should see the container image appearing in the artifact registry repository I configured. Let's see if it's there. It was empty before. Okay, as you can see, I have the image appearing here with a tag that is the same of the commit that is the commit of the pull request. Then I should see the release starting. This is queued, and especially on the EKS cluster, as I said, this is in public preview. It could take some time, but let's see. This happening. Let's move also on the EKS cluster. Okay, let's see if I see some new service or pod on the EKS cluster. For now, I see only the Kubernetes standard. Okay, the rollout is started. It's queued at the moment. It uses some queues, so it's not immediate, and it's not showing in a demo. Is not super quick. Okay, this is in progress at the moment. He rendered the manifest, and now he's with scaffold render, and now he's creating the actual deployment. Okay. It used the gateway config I showed before, so it needs to connect to Google APIs and then back to the cluster. Okay, and here you can see that the application started to be deployed to in the EKS cluster. We have the service exposed. Hopefully, we should be able to connect to it, the application, with the change that the developer wanted to do. Okay, still not ready. It's on the I'm running out of time, but it will take only 1 minute. It's not immediate thing. I like to do live things always. This learning in public stuff. Okay, still not responding, but sometime it will. Let's see if in the meantime the deployment, the rollout finished. Okay, still in progress. Okay, now it's deployed in QA. Now that all the tests in QA are okay, I can decide to merge the pull request. Confirm merge. Okay, maybe I should have waited that the rollout was finished, but I'm running because I'm conscious of time. So I'm not sure this will go. Because the second trigger will promote the release, but if it doesn't find the release there ready, this will not work. Okay, so this will promote the existing release to the production target. But for this to work, the QA rollout should be finished. Let's see. Is it pulling the Cloud SDK image to promote the release? Waiting, waiting, waiting. Okay, the QA. This is the risk of showing things that are in public preview. Okay, this failed because the release was not ready. I think that for the sake of time, we should stop, right? Let's see if at least the first one went. Okay, yeah, this should the first release should complete, and then executing the second one after the merge should promote the release in production, also asking for approval. I think I'm 4 minutes outside, so I really thanks a lot for being with me with that. Sorry that I wasn't in exactly time for this, but I like to show like this.
Thank you very much, Giovanni.
Even if it doesn't always work, we do love a live demo.
Me too. I love it.
That's the spirit. Do you think we should take one question and then move on in the matter of time? I think the highest voted question with 2 votes was, can infrastructure as code in brackets Terraform also be used to manage the infrastructure or integrate with the chain that you introduced?
Yes, absolutely. We have examples where Cloud Build specifically is used to deploy infrastructure too. No? And we have also colleagues and people showing this tool chain, not starting from the code from the developer, but starting from the infrastructure provisioning. So it's actually there are Terraform providers for Google Cloud, and there are also and typically are used with Cloud Build Builder to automate also the infrastructure provisioning before the code provisioning.
That sounds cool, and that's basically everything that the person would need. Also, okay, the cluster management with Anthos.
One other note: we are also exposing infrastructure with the Kubernetes config controller that expose GCP infrastructure construct as Kubernetes resources. Oh, now it worked. Just 1 second. As you see, the release was promoted, but it asked for approval. So let's pretend that now I am the up release team, and I'm approving the release, and now I have a new rollout in production. Okay, just I will not see this happening, but I want to show the whole cycle. So at the end, I was able to show that.
So it did work.
Thanks.
Congratulations, and thank you for the last time. And I think as time dictates, I'm sure we could spend a lot of time. We could discuss about pipelines for a long time, but we must move forward. So thank you, Giovanni.
Thanks a lot, Marcus and Marcus. Bye-bye. Thanks a lot to everybody for being with us.